Welcome to the AI for Career Success video overview by Curt Robbins, where we help you get smarter than your competition. I'm your host, Susan Johnson. It's a phenomenon many of us have likely observed. AI can seem brilliant one moment and then utterly baffled the next. Today, we're going to explore a framework from Ethan Mollick that offers a powerful new lens for understanding and perhaps even anticipating the trajectory of artificial intelligence. Our discussion will begin with the central paradox of AI's abilities. From there, we'll introduce a model to help explain it, and then we'll conclude with the strategic implications for professionals who are navigating this rapidly changing landscape. So let's start with a core confusion surrounding artificial intelligence: its profound inconsistency. How can a system perform at a superhuman level on one task and then fail completely at something that we would consider quite simple? This is really the paradox at the heart of modern AI. It can excel at tasks we find cognitively demanding, yet struggle with things a child might find intuitive. Mollick argues that to make sense of this, we really need a new mental model for how AI progresses. To resolve this paradox, Mollick proposes the concept of the Jagged Frontier. It's a useful metaphor that helps us move away from thinking about AI progress as some kind of simple, steady expansion. In essence, this term describes the uneven and unpredictable landscape of AI's capabilities. You see, progress isn't a smooth, expanding circle. It's much more like a spiky, irregular line, with surprising peaks of superhuman ability right next to deep valleys of incompetence. So, instead of a predictable, uniform advance, the reality of the jagged frontier means AI can leap far ahead in areas like complex reasoning while significantly lagging in others. A prime example of this is permanent memory, the ability to learn a new skill and retain it. It remains a stubborn weak spot. Now, this jaggedness isn't just a theoretical concept. It has direct and very significant consequences in the real world. These consequences create what are known as bottlenecks, because a system, after all, is only as effective as its weakest component. So where do these bottlenecks actually come from? Well, sometimes the AI is simply not yet capable enough at a critical part of a task. Other times, the bottleneck isn't the technology at all, but rather slow-moving human institutions, like regulatory bodies. And quite often, a human is still needed for those rare but crucial edge cases that an AI just can't handle. To really appreciate the impact of a bottleneck, let's look at a recent study on producing Cochrane medical reviews. These are incredibly deep meta-analyses that traditionally represent about 12 work years of effort. An AI was tasked with screening over 146,000 citations and performing the required statistical analysis. It completed the work in just 2 days. And not only was it faster, it dramatically outperformed human reviewers on accuracy for that core intellectual work. It's a truly stunning acceleration. However, and this is the key point, the process couldn't be fully automated. The AI was unable to perform simple ancillary tasks, like emailing authors to request unpublished data. So that simple task, sending an email, becomes the bottleneck. Even though the AI handles over 99% of the cognitive heavy lifting, the entire workflow can't be automated because of this one small gap. Now, these bottlenecks aren't permanent. When one is finally solved, it can lead to a sudden and massive leap in capability. To describe this phenomenon, Mollick borrows a term from the historian of technology Thomas Hughes: a reverse salient. So what happens when a key weakness, a critical bottleneck, is finally fixed? Well, progress isn't gradual, it's a sudden leap forward. A perfect example of this is AI image generation, which was a major bottleneck for a very long time. If you look back to 2021, a simple prompt for an otter on a plane using Wi-Fi would yield this: a poor, abstract, and largely unrecognizable image. This really demonstrated the profound weakness in AI image generation at the time. Fast forward to today, and a far more complex version of that same prompt produces a photorealistic and contextually correct image. This illustrates very clearly that the bottleneck in high-quality image generation has been decisively broken. This kind of breakthrough immediately unlocks tasks that were previously impossible. For instance, generating slide decks. Before, AIs had to write clunky code to create visually dull slides. Now, they can generate each slide as a flexible, visually rich image, adopting any style imaginable. So, what does this framework of jagged frontiers, bottlenecks, and reverse salients actually mean for us as professionals trying to anticipate the future? It gives us a much smarter way to watch AI and understand where it's truly headed. And here's the key takeaway from Mollick's analysis. If you want to know what's coming next, you should stop focusing on the general performance benchmarks. Instead, watch the bottlenecks, because those weaknesses are precisely where the next major breakthroughs are developing. The critical question, then, for any professional is to identify the next reverse salient. Will it be permanent memory, or perhaps real-time learning from interaction, or even the ability to take physical actions in the world? When a bottleneck like one of these finally breaks, progress won't be gradual. It will be a sudden lurch forward.
Thank you for watching. This is where we teach you AI and help you get smarter than your competition. To continue learning with us, subscribe to the AI for Career Success YouTube channel. Please like, comment, and share this video to help us reach a wider audience.